We're going to have a talk now about the underlying plumbing of the internet, specifically the routing infrastructure. We're going to change gears a bit now and, of course, have a bit of a lively discussion with our panel that is currently being mic'd up here. The underlying routing infrastructure has served us very well, almost 2 decades. The current protocol and even farther back on previous protocols, we've been running on it. And it served us very well with very few headaches. But as the internet grows, we've been hearing more and more that there potentially are problems, or there's scaling or reliability issues. You know, you hear news reports or of routing issues where whether it be malicious or just a fat finger, certain sites or parts of the internet disappear for a bit. So we're going to hopefully discuss that a bit. You know, what is the current state of affairs? Is there actually anything wrong? Is there a real problem to be solved? What are the solutions available, you know, and that we can use to either mitigate or enhance that? And is it even really worth the effort? So with that, I'm going to introduce the panel that we have assembled here. I'm just going to give this pen. So first, going from my left to right, we have Sandra Murphy, who's the principal investigator at Sparta. Sandra Murphy has served as the principal computer scientist at Sparta. Her primary responsibilities over the last decades have concerned research and development in the design, analysis, and verification of various competing networking protocols. She's been the principal investigator for several government research projects addressing security for network protocols funded by DARPA, DISA, and ARL. And currently, she's the principal investigator of a DHS-funded project that seeks an acceptable, deployable security solution for routing infrastructure. She's active in the IETF and is also, as we heard, was the co-chair of the SIDR working group and is also an active participant at many of the operator and RIR forums. She's also authored several IETF RFCs and of the journal and conference papers, and has served on the technical program committee of many of these conferences. Prior to joining Sparta, Sandra was worked for Trusted Information Systems and Network Associates Laboratories, which is now known as McAfee, and where she began her work in network protocol security research. And previously she was with the Defense Communications Agency and have earned a PhD at the University of Maryland. So welcome to Sandra, please. Thank you. Moving right on, we have apparently the wrong piece of paper. Sorry about that. They went in the wrong order for me. We have Merike Kaeo, who's the security evangelist at Internet Identity. She leads IID's information sharing and collaboration partnerships. She actively contributes to the IETF in such areas as IPv6, routing, and security, and speaks globally around the world at events such as this, and NANOG, RIPE, SANOG, to name a few. She's also a member of ICANN Security and Stability Advisory Council, and her main focus is in bringing cohesiveness to security-related concerns across the overall internet landscape. And prior to joining IID, she founded and served as the chief network security architect at Double Shot Security. She has authored numerous books and technology papers, which are leveraged for a variety of security accreditation programs. Thank you very much. Next, moving on, we have Eric Osterweil, who's the applied security research in the security office at Verisign. Eric is an applied security research at the CSO office at Verisign. Received a PhD from computer science at UCLA in 2010, where his dissertation topic was a new substance for internet scale security systems called measurable security, which I think we've already heard once about today. His research interests center on DDoS attacks and remediation, systematic dependency analysis, and the security internet scales like DNS, DNSSEC, and BGP. And finally, Andrew Sullivan, who's the principal architect at Dyn. Andrew brings a pioneering spirit to their DNS team, ensuring the company is always looking toward the future of the internet. Previously worked on the future innovations for Dyn as the director of their labs, and he's been a long leading voice in the DNS and internet community, and previously worked as the director of name services at Affilius and as the internet scientist at Shakuro, and has also been an active member of the Internet Architecture Board and IETF. And with that, I'd ask you to welcome our panel. So that's the end of the stuffy stuff for this panel. For those of you who've been at panels in this forum, they always tend to be, you know, we'll have each panelist come up and speak, of course, for 10 to 15 minutes, lots of slides, and then hopefully we can squeeze in 2 minutes of questions. Not today, though. Today, there's no slides, no prepared. I've got a few questions that we'll get started, but what I'm really hoping is the questions will come from you. So as soon as you have a question, put your hand up. I'll jump in Phil Donahue style into the audience, and we'll be happy to address your questions. So please do that. But so we can level set a little bit for our panelists, just a quick question. Put your hand up if you in your day job interact or are involved in network operations on the core of the, in the routing infrastructure? Okay. How about if you have heard of RPKI, deployed it, played around with it? You don't count. All right, so a bit of work down there. Okay, so what I'd like to get into first is first just deal a little bit and ask each panelist just to basically ask, is there actually anything wrong with the routing and security and stability of the internet system as we have it today? What kind of problems are operators and researchers seeing in the routing system? What kind of impact? And I just ask, we'll start with Andrew and move down this way just to kind of give their quick 2 cents.
Oh, good. I think that fundamentally, since the routing is even lower in the stack than the DNS, and we've already got a problem with the security of the DNS level, we have to worry about how the routing system generally works, because voluntary interconnection is really the fundamental way that the internet works. And so you need this kind of, you need to know who it is that you're talking to at the other end. I don't know, however, that all of the solutions that we've got proposed so far are going to solve everything that we'd like them to.
Thank you. Eric?
So that's an interesting question to put to me. So I mostly take my answer from having spoken to a number of people, like the people that raised their hand in the audience, the operators. And so having sort of the position I sit in is that I like to try and look for problems that exist. And you guys are the ones that actually hit the problems, and you're the ones that actually see them. And so the problems that I see in the routing system are those that I've heard echoed through people, and maybe I've tried to digest them and come up with a principled view of them. But they've mostly come from people that are actually on the front lines and talking about them. So things like route leaks, things like misoriginations, things like that I see as real route security issues. And it's not because I think from an ivory tower I see them and I think I know something about them. It's because I talk to people like you. And I try and understand what the problems are from people like you. And I work with our internal systems people and our internal operators and the community of operators. And I look to solutions that have sort of operational feasibility. And again, as a sort of a principal scientist, I try and factor those into something that I think I can sort of build a case upon. So at a high level, that's kind of where I stand.
Thank you.
I think from a security level, there's multiple factors to be considered. Availability is also very much a part of looking at security functionality. And I think when you're looking at routing stability, there's issues that can be either malicious or also unintentional misconfigurations. But what the issues that they cause in terms of sending routes in the wrong direction, traffic in the wrong directions, which may be used for malicious intent, I think we do have to look at how do you actually ensure that from a routing infrastructure you have the integrity and the availability that you need.
The statement that you made at the beginning was that as the routing system progressed and grew, that we began to see problems. From what I've seen, the problems existed from the very beginning. In the old ARPANET days, we had cases where routers would report that they were UCLA when they weren't, or that they were the path of link 0 to every place in the world. They became very popular. Some of the most widely reported incidents that we've had similar sorts of characteristics, particularly routers and ASs reporting that they had really short paths to everything. The two very prominent cases were a small ISP in Virginia way back, AS 7007, and the Pakistan PCCW announcement of YouTube. These are widely known, but cases like them appear all the time. And it's the fact that they occur very often which points to BGP just has vulnerabilities. It works because most of the people involved are good internet citizens, but there's no protection against things that might be deliberate or just a bad day.
But so you say that there's obviously the two known incidents. There was the or at least well publicized YouTube, and that but you're suggesting, I guess, that these are much more common, so we're just
Yes.
not noticing them, I guess, or the average user just sees it as either a blip, or by the time they call in, it's already resolved itself. So I'd ask, maybe Andrew, is this really a problem? Like, how often is this occurring, and should we really be putting resources to fix it? Or is kind of suggest if these problems have existed so long, have we just gotten used to them?
So when you make a phone call today to, for instance, 911, you're going over the internet. So frankly, yes, this is a problem. We're going to have to accept that the internet is increasingly critical infrastructure, and it's critical infrastructure that's based on best efforts, foundation. And that foundation is not an optional part, so we better get this right.
But, and I'll go to Eric, isn't it a best effort basis? Like, why am I concerned? That's what I'm, other than sales reps who would tell you they'll have 100% SLA, most people would be of the theory that the internet's a best effort. It works most of the time, but you shouldn't be relying on it for, why are we relying on it for something like 911?
Oh, I think we're relying on it for something like 911 because it's become economical to do so. I mean, I think there's a handful of questions sort of interwoven there. It becomes very complex, obviously. And I think that the simple, straightforward answer is why are we using E911 over the internet is because that's how we can sort of pervade into wireless, into handheld sets that can sort of move between networks and move around in our cars with us and still get locality of information or of emergency services and so on and so forth. But I also think that we should also remember that the threats that we face are not one kind of threat. There's different kinds of problems that we face. And so saying like there's instability, there's fragility, sort of like Merike said, there's lots of different reasons why we would have an outage, and there's lots of different types of outages too. So one way we could do ourselves a disservice is to put too many things that are dissimilar together in the same bin and then say this is a problem or this is insurmountable or not.
Okay, and without getting into anyone who wants to jump in, the actual solutions, there have been a variety of improvements proposed or in the cycle or even available, some for a few years, some for many years. Why is it, if there are these issues and they do have these real impacts, operators aren't moving to deploy them? Just in a more general sense before we get into any of the specifics.
Yeah, I'll
Merike?
actually answer this. Part of what I've done in the last 15 years is travel around the globe and teach people about how to secure their networks. And the routing infrastructure is a big piece of that. It's been a little bit frustrating to see how little people actually do filtering, either on a packet level or on a routing level. And sometimes it's just that people don't understand what filtering will buy them. Plus, it's for an operator, it takes time to figure out what filters make sense on a routing level. And you always have to look at backdoor environments, right? I mean, if a path goes down somewhere, to make sure that you take those prefixes into account, that you don't filter them when they're needed. And I think that filtering, in my mind, is something that really people should be paying more attention to, and then also other new technologies that are coming into effect.
Sandra, you've been involved in a lot of watching these new technologies develop. What's some of the frustrations you've seen and why we don't see more deployment?
Best current practice for protecting against misoriginations that Eric referred to is to build prefix filters, usually based on information stored in the routing registries. There are lots of different routing registries. They're run with good intentions in some places. Some of them are very widely used. But there are problems with authorizing the data. There are problems with staleness of the data. Some people will report problems in they have so many prefixes coming over an interface to a peer or a customer that their routers don't have the capacity to deal with filters that have 50,000 prefixes. So we have a problem with resources. We have a problem with education. Every NANOG meeting I've been to has had some mention of routing filters, but still there's not widespread use of those things. And we have problems with the data itself. Some of the new work that's going on in the CIDR working group is to try to improve the data and make it possible to use that data in the enforcement of routing decisions without requiring building prefix lists. An easy way of making use of the new data is to feed it into the prefix filter engines that people have, but there are other ways to do it which are less resource impact. So I don't know.
Okay. Anyone else want to jump in before we jump into some of the actual more specific problems, I guess? And this is the point I'm going to say. I open it up now to the audience. So if you feel like a question, wave your hand madly, and I will be with you in just a second. And I'll just start, though, with, let's just talk. We talked a lot about filtering. Filtering has come up. Merike, what are the kinds of filtering that ISPs should be looking at and or, more importantly, not doing? Because I think you could break it down to that there's two types almost of filtering that we'd be talking about.
Yeah, there's two types. There's either in BGP, it's AS path filtering or just prefix filtering. And prefix filtering is something that really every ISP should be looking to do, either customer facing or also with their peers. AS path filtering, is also something that many ISPs are looking at, but it turns out that prefix filtering, a lot of ISPs usually find to be easier. Another comment I want to make also is that the more automation that can be built into devices will really go a long way to getting better deployments.
Okay. Can I have the hands again of all the people who are providers of some kind? Hand up, please, all that. Okay, now put your hand down if you're, no, keep them up. I didn't say you could put them down yet. Put your hand down if you are filtering both your origins and your paths. This sounds like it's a, but hold on, no one has their hand up anymore, or are you just afraid because you know what I'm going to do next to you? Oh, we have one thing. All right, here we go. So why?
To control where.
You are filtering or not filtering? Yeah. Oh, no, you're not the good example. All right, well, why are you, so who's not filtering then? Who's not filtering their customers' prefixes, or no one will admit to it? Wow. We apparently found the sample size of perfection, so. Oh, okay.
I have a comment. So in some situations, especially when you're dealing with large providers, especially in peering agreements, you end up with companies like HE, for example, who advertise 10,000, 20,000 routes. Prefix filtering is not really, you put a limit and that's about all you can do. You can't really say, I'm only accepting these routes from them. So all you can do to prevent any sort of leaking into your routing table is to put an up limit. And then if they introduce default gateways or routes that don't really belong to them, you're sort of, on the fence there. But that's the comment that I can make.
So I heard Merike say that she suggested people do customer and peer filtering. I have heard from many ISPs that, and the usual recommendation is filter your customers, but that people seldom filter their peers precisely for the problem that you described. There's just too many routes coming through that peer interface. So how many people filter their peering connections?
Just the Torx gentleman in the back. Oh, and sorry. Oh, Mr. And
right.
Gabe from Tech Savvy. I see you there. Not a lot, though.
Yeah.
Yeah, and just to clarify, right, my statement was more in that you have to look differently in how and what you filter depending on whether or not it's your customers, your peering, or even through transits. And I will acknowledge what Sandy was saying. Customer prefix filtering is absolutely something that is the most important, really.
So Eric, BCP 38, which talks about the filter, that kind of practice of filtering is around 13 years. Even though this room, we seem to have found the perfect room that everybody is filtering their customer. We don't generally see it on the internet. But what are some of the concerns that you've seen for the people who didn't show up, that or on the webcast, we'll assume that that you've heard, and some of the concerns you might have?
So this is interesting. So I pull a lot of what I come up with from people like this. So now I'm reporting back out to the people, the things I've heard. So what I guess I'd say is that I think I understand that one of the most central problems with filtering that you as operators face is knowing basically who is behind who you're paired with. In other words, you can't apply a filter to someone without knowing for sure that they're not actually providing transit to someone behind them, which actually was what I was going to jump in to what Merike was saying, which is that it kind of takes a village. It's not like you should look at the biggest ISP and say, why aren't you filtering? It's more like, why aren't we all filtering? And as that gets closer to the edge, you get closer to where you can actually deal with the real problem. So the real problem is being able to go to edge networks and be able to get them to bounce traffic around for you to launch a reflector attack or something like that. We heard earlier today, someone said, well, why would you do DNSSEC when clearly that's the reason that there are these giant reflector attacks? I was like, no, I think Merike pointed out, that's kind of a routing problem. That's a filtering problem. And that has a lot to do with the edge networks. It has a lot to do with big transit providers. And there isn't a one-size-fits-all. Just like a second ago when someone said, we filter on some of our peers. Exactly. I mean, filtering is kind of a mindset. It's kind of like I should be careful and circumspect about what do I allow, based on what do I know, based on what I can know. Going back to something Sandy said, there's imperfect data out there and so on and so forth. Agreed. And there's some places where some data, particularly customer data, is taken care of much more carefully than what's wildly replicated through giant IRR systems. So I hate to say it, but it's not a one-size-fits-all, but I suspect I'm preaching to the choir on that.
Quickly also, Andrew, Dyn runs obviously a very large, different than most providers, but a very large network for its Anycast and all that. And of course, DNS has been kind of there's been an increase, it seems, or DNS has been a bit of a target. What's some of the stuff you've seen? Because I guess you've been on the receiving end of a lot of those non-filtered packets. So.
Right. So it's certainly true that it's certainly true that there's a lot. There must be anyway a number of networks out there that are not filtering because I see a lot of this traffic, and I know that all of my competitors do too. I guess the real question is, do we take this seriously enough that we're going to do something about it? Because we're going to find that somebody's going to come along and make laws for us if we don't do something about it. Now, what I have noticed in recent years is that the problem is actually getting worse. So it used to be that you would see an attack, you'd see some sort of reflection or something, and it'd be in one or two of our Anycast sites. And so what that indicated is that the botnets tended to be concentrated within certain providers, and then you'd tend to get the traffic via those ones, and you could shut them down pretty quickly. Once you figured out where the traffic was coming from, there were certain people, and you just start to throttle their pipes. Now we see actually that, so we're currently running about 20 Anycast sites, and we sometimes see traffic that is distributed across the entire network. And as we ramp these things up, we see traffic showing up in sites even as we're turning them up, which suggests to me that the attackers are very, very widely dispersed, and they have a pretty good idea of who is not filtering and who is. So that suggests that we need to clean up our own house.
Or be ready for the regulator.
Well, right, exactly.
Any CRTC or regulators in the room? There's some in the building, I know. So be wary, sir.
Hi, Andrew. Thanks very much. You've partly answered my question before I asked it. I'm just an end user, and I'm fascinated to know what the nature of the traffic that you're filtering out or should filter out is. Is it packets with bad source addresses that are forged source addresses, or?
Yes. So in effect, when traffic leaves your network, you are saying this came from inside my network, and if it's coming from inside, if it's coming from an address that you shouldn't be routing, you shouldn't send it. It's not. I mean, what's funny, of course, is that if you're familiar with the jargon, right? People start saying things like BCP38 and so on. But the plain message for people who are up in the management layers or something, if you need to get the clue, is we should never send anything that couldn't possibly have come from us. And that shouldn't be a hard sell.
Right, but everybody agreed to that one was a no-brainer, but the problem is transit and so on, right?
Well, certain kinds of providers can't do this, but of course, if you are a transit provider, you know who's on the other end of that link. So you know what they should be sending you. But of course, I mean, there comes a point where, we just heard some others saying, well, I can't, there's only so much I can do. So this is, I think this was fundamentally what Eric was saying before, that it requires actually intelligence at every level. You can't sort of expect that the answer to this is going to be, we go to the great big giant routers and we have like all the filters there. No, it should happen all the way along. If you're going to have a reasonably secure network, This is a little bit like a reasonably secure city. Part of the reason that Toronto is such a pleasant place to come to, for instance, is because there's people on the street all the time, and people are looking around, and they're paying attention, and so on. And if you go to a less pleasant city, the answer for security is, oh, well, we'll send the cops in, and they'll just keep order everywhere. Well, that doesn't really work. What works is to have a sort of activity of a friendly neighborhood where people are paying attention all the time. And that's similarly in the routing system. If you are paying attention at every layer all the way along, it seems to me we get a better system.
Thank you for that. We're going to change gears in a second, but first we have a long-time listener, first-time caller here with a question.
Thank you, Mr. Donahue. I can understand. Jean-François Mézy, Vaccination Informatique. I can understand an ISP filtering packets going out that don't have a return address that belongs to him because you know what your IP blocks are. Isn't there a problem filtering packets from a peer when you don't actually know exactly what IPs he has and what IPs added last week without telling you? Isn't that like a big problem in terms of management?
So I could jump on that real quick.
Yeah, please.
So yeah, but again, let's not put too many things together. So if I'm a customer and I want to tell my provider with a flow spec filter, please stop sending me this traffic, I ought to be able to do that too, right? So I mean, but that's different than like a settlement-free peer, where we're exchanging information or whatever. I mean, so there's different situations where I can say certain things, but at some point, if I'm getting a lot of packet love, maybe from multiple upstreams, I may want to push to them filters, and as the customer, I should be able to do that if I've decided I know how. So sometimes yes, sometimes no, I'd say.
Yeah, and there's absolutely different levels of filtering, right? It's never a cookie cutter. And I think, a lot of people, they just want the answer. They're like, how do I create my filters, right? And the best example I have is the Bogon filters that Team Cymru feeds you, right? A lot of people just take the feeds, plop it automatically into their filters, away you go. Well, for
Could you, for those that may not be aware, give a bit of a 10-second?
Yeah, so Team Cymru is a company that does a lot of good things in terms of security. They're a nonprofit. And they provide what's called Bogon and Martian filters for BGP. And these are basically reserved space that hasn't yet been routed. And so you should be filtering on them because you shouldn't be seeing any traffic coming from these allocations. And so they provide an automated feed that a lot of providers just used for creating routing filters. And so the automation is what a lot of people like. Obviously, you have to have full trust that their feeds are accurate. And they make a great effort to ensure that that's the case. So whenever there's a new allocation, they'll update that right away. And they're very much involved with the different RIRs to see what allocations have been allocated.
Any more questions from the audience? Okay, we'll be right there in a second. If you put your hand up and ask a question, I'll try and convince them when they pull the draw to try and for the iPad to, no, I'm kidding. Sandra, any final, sorry, Andrew?
Well, there is one more thing that I want to say, and that is, you sometimes hear, well, everybody's outbound filtering, and then, we have this problem of filtering inbound, and we don't really know how to do it because we don't know what is on the other side of the link and so on. If everybody really was outbound filtering correctly, then we would never have a problem. So it can't be true that everybody's doing this, because you wouldn't have a problem of bad traffic coming from somebody if, in fact, you had good filters outbound everywhere. So I think that you have to look at what your peers are doing, and if you're getting a lot of garbage, you have to start to ask, well, what are their policies back there? Maybe people aren't doing it, and I think we need to build some reputation systems around that.
I'll also make one more comment. I've done a lot of security audits in a past life, and what was always interesting was when people thought they had certain filters, and I said, well, I just want to look at your config, just to double check. And it turned out that they're like, oh, oops, yeah, we had an outage. We took away some of these filters, and then they forgot to replace them again. And so there is a clear lack of an auditing function. You may think that you've put in these filters, but your operational people had to troubleshoot something and then forgot to actually replace the full set of filters. So that's also an issue I see in the industry.
got Gabe
There's
from Tech.
also one other point.
Sorry, we've got Gabe from Tech. Do you remember to check your filters after you turn them off for a second? No.
Not always, to be honest, no. But yes.
You had a question, sorry.
It's not really a question. It's more of a, I guess, to point out that I believe it's in the Internet Society that provides a tool called IRR Tools. I forgot who it is. It's really a great tool that will generate prefix list filters based on the routing registries. And you can just literally copy paste them in your routers and it will take care of everything for you. It doesn't work very well for something really big peers, but it works well for, just in general for exchanges. Yes. But yeah, no, just wanted to point that out. I think there's more than one tool, but IRR Tools is the one that I can think of right now. Takes care of that. And anyway, that's pretty much it.
There's also the IRR power tools. I've heard that one described also. But one comment, the routing registries themselves have a certain amount of problem with the data. You probably have those of you who have used routing registries have probably heard proxy registrations. And that's an ISP who discovers the customer has not registered their route, knows that someone later on is going to filter based on the routing registries and drop the route. And so they create a route object on their behalf. And that's fine, unless they shouldn't. There's no way in the routing registry to really control that part of the system. The other point is that when the person who said that they had 10,000 routes coming from their peer is going to get those 10,000 routes and who knows how many others from other customers. There comes a point in this, in the progress of routes where you could be getting any prefix over that interface. Between two tier ones or a tier one and a tier two, the prefix filter list is not going to filter out very much because just about anything would be valid to come over there. So if you can do it at the leafs, that's fine and that will work. Further on deeper into the backbone, that won't be as effective.
So we're going to shift gears in a second, but Eric was just going to...
So I think that misses an important point, though. So I think the point of the IRRs and the RPSL objects is that you can construct policy information. How you employ it, what you do with it, where you put it at a large transit peering link, or you simply go back and you look at the source of a route leak, and you can then determine realistically what was happening is important because it's a semantic that doesn't exist in a lot of systems. And it's something that people are to the point where there's a handful of tool sets some people are familiar with. And so in as much as there's a lot of crufty data, in as much as there's a lot of issues with system level elements of that, it's important to know that there's a semantic there that's useful for dealing with a certain type of problem. And there's a lot of work going on, various people in various groups, to say, what could you do if you could actually get this policy information? What would it tell you? Because again, you may not want to necessarily prune traffic as it goes across a really fat transit link if really what it is a route leak farther down, when you could go and learn through some sort of resource certification mechanism that the policy was violated farther down. That's what you want to know when you're dealing with this stuff.
Just a quick TLA check, three-letter acronym check, IRR, Internet Routing Registry. Who knows what we're talking about, just so we're not... Oh, Eric, did you want to give a quick, just for those that may not be familiar?
Sort of at a really high level, the Internet Routing Registries are basically, at a super high level, it's a place where people can take policy information about themselves and their peering arrangements, among other things, and they can put it in a place where others in the internet can download it and consume it. And based on a lot of history, there was a period where massive replication was done so that you didn't have to go to the right place. They'd all replicate with each other. And part of what Sandy mentioned before, proxy registration, was if it's incomplete, go ahead and fill it in because we're all kumbaya, a bunch of well-meaning operators, and we won't lie. And that way we get a complete view of what should be allowed and what shouldn't be allowed. And a lot of people, I'm going to skip any sort of malicious intent. A lot of people lost track of things, put multiple entries in, things were replicated by other people on other people's behalf and were authoritative. So there's a missing component, which I call resource certification, where I am the rightful resource holder of something. I've updated this policy as of this time. You can use it versus I found this thing somewhere in the interwebs. And so IRRs are a place for me to go out to the interwebs and find policy information routing.
So the RRs, the regional internet registries, they have the IP addresses. They maintain, obviously, registration databases. These internet routing registries, some maintained by the RIRs, some not. but I'm guessing, I'll throw it up to Sandra, I guess, first. How accurate is this data? Can we rely on it, 100%, or, because we're going to start talking about RPKI in a second, and where we start having the router do a bit more of the decision. How much should we be trusting this? Sandra, you look like you're about to jump out of your chair on that.
It was a point of order question.
Sure.
There are regional internet registries. All of you are in the ARIN registry. That's where you go to get your prefix allocations. You're familiar with that. There are IRR's, internet routing registries.
Oh, did I mix it up? Did I make the classic mix-up? Oh.
Somebody who decided that RIR should run IRRs really needs to be taken out and educated.
It's a kid show here. We have to be careful with it.
But the IRRs based at RIRs have the means at their disposal to check whether the person making the registration is authorized to speak for the prefix because they can see both databases. This is not the case in all the IRRs that exist in the world. So that leads to the problems with data authorization, authentication, staleness. There was a wonderful presentation at an ANOG meeting maybe 4 or 5 years ago, and a gentleman took the routing registry data and compared it to the routing system as those routes that were registered but not in the BGP system, or in the BGP system but did not appear in the routing
And there was a
registry.
100% matchup, no problems whatsoever.
Absolutely, it was just like this crowd. No question.
Any other comments from the panel on just the accuracy of this data? What is the problems with keeping it accurate? Because if we're going to start trying to up our game, wouldn't that be the first place to start, or is it just a lost cause after all these years?
No, I think there's a lot of effort in the industry to actually try to fix the problem with internet routing registries. We're not even close as far as I'm concerned. But I do think that the effort is being made, and I'm hoping that we can get to a point where you will have a trusted internet routing registry or set of registries, right? So there's cohesion across them. But I will also make the statement, because this also speaks to what we've heard earlier with BCOP and all those other things, is that if you're building a network and you're architecting something, don't just cut and paste. Please validate on your own. Because you just, the information is coming from somewhere, and you may have a little bit of a different environment. So please, as internet network engineers, right, the engineering part is very critical, is trust but verify.
Yeah, and just to jump on that real quick, and if you write tools that help you do that, and you have any way of open sourcing that tool to help someone else make their life easier so they don't copy and paste, but maybe they generate this, even if you think, oh no, my Perl is really crufty, or my Python is terrible, please just throw it out there.
Yes, do good. You've all relied on free tools. It's always good to contribute one back. We have another question over here from this gentleman again.
Yeah, I was just wondering, Andrew, you said a while back some kind of reputation system might be good for the filtering. It seems completely obvious that you're right. Why hasn't it happened? The obvious level would be a certification saying, all stuff coming from me is good, I swear, and I will therefore get dropped if I'm lying. Or some back propagation channel, official channel for noticed errors, so to call them. Packets that didn't belong, a back channel to go back to where they came from.
So first of all, there are some reputations. There are some reputation systems. That's essentially what the Bogon list is. It amounts to a kind of reputation system, but they're not as common as the most common reputation system that we know on the internet today, which is essentially the anti-spam black hole lists. And part of the reason that we don't have the same kind of aggressive reputation systems as we do in the email space is because if some email doesn't make it there, then the email doesn't get through. If some routes don't get there, then the internet stops, and your customer support costs go way up. And so part of the reason I think that these reputation systems have not taken off to quite the same extent is just because people are afraid of the costs. excuse me, I'm sorry about the cold. I think that the problem is if we don't figure out some way of saying, oh, you know, we're going to deprioritize traffic from these bad sources, then eventually the people who would like to make regulations are going to figure out how to do it instead, and they're going to make it in, you know, in the absence of real understanding of what those regulations are going to do. A couple of weeks ago, I was at the Internet Governance Forum in Bali, and one of the things that, you know, came home to me pretty clearly while I was there is that to a regulator, everything is a regulatory problem. When something is working well, I heard this several times during the opening statements, people were saying, oh, this is working so well that it's grown over time, therefore we need some regulations in order to make it continue that way. You know, if you come from an engineering background, that's a very strange thing to hear, but it's a natural thing. Much worse if you've got real problems. That is, you know, that's an attractive target to somebody who wants to make rules and who's going to stifle your ability to do innovation on your network.
And I can attest, Andrew's correct. Engineers and regulators it can be an interesting mix. Again, you don't have to ask a question, by the way. If you have a comment or you disagree with what's been said, feel free to throw your hand up. We've got a question or a comment over here, and then we're going to shift a bit.
So, Jacques Lato with Sierra. So I got a question. IPv6, I was talking to a bunch of people, and we can't run v4 for another 20 years. So it's proposing that we shut down v4 on April 4, 2024. So 4/4/2024. That's 10 years from now. You think that's something we can do?
Not quite a security stability, but if someone wants to take a stab at it.
Stability.
Or it'd be a stability when it does turned off.
No, I was trying to figure out how to bring in V6, right? And I got to tell you, like, it's amazing to me that sometimes people will start deploying V6 and totally forget about filtering. You know, and I've done enough, you know, assessments to actually see that. They're like, oh yeah, you know, like, you know, they're playing with it in their routing infrastructure and turning it on in their backbones. And then I look at them, you know, and I look at their configs, and I'm like, why are you not filtering anything here? And they're like, oh yeah, right? Even though, you know, with v4, they're pretty strict about filtering. So it's interesting to me that we haven't learned anything in the last 20 years, and that security is still an afterthought. So rather than being architected into how you're, you know, creating your networks, right? You're still trying to figure out how to get from point A to point B, and then going, ooh, I don't want everything going from point A to point B, right? What do I do?
So let's switch topics a little bit, and we've heard the concept of RPKI, and there seem to be some people did know about it, but not. Sandra, maybe you could just give us an explanation for those that aren't aware of what it does, or at a high level, and then we will debate it to the death.
Not to death, please.
That's only happened in the last 10 years.
Okay, so I spoke with Aaron, and Aaron is how you get your prefix allocations. And people get prefix allocations, and sometimes they allocate some of that address space to their customers, and chains can be, Aaron tells me they see chains is 5 or 6 deep. The RPKI associates a certificate for each one of those allocations that says, Aaron gave me this address space, or I gave this address space to my customer. So you have a certificate hierarchy that proves that you have the right to use a prefix. Then with that certificate, you can sign a route origin authorization, which can be used in routers to judge BGP routes to say whether they should be allowed or not.
Well, Eric, that sounds like a great idea. Why are we not? And I hear it's in my Cisco and Juniper, and your vendor of choice. We'll sell it to you tomorrow. Why are we not? Why is not everybody on it already? Because we have seen not a lot of uptake. Actually, before I go to you, because I think some of the stats we've seen worldwide on actual RPK uptake. Because we're weird here.
The surfnet.nl was referred to earlier as having a DNS deployment. Well, Lord bless them, they have an RPKI site also. I was looking at it earlier today, and it's been observed that RPKI uptake is outpacing IPv6 uptake, which is an interesting state to be in.
Considering we're running out of v4 very quickly.
Yeah, I think it was like 11% of the RIPE addresses close to 20% in LACNIC. They've really done well. I won't say Aaron's percentage is too discouraging.
The gremlins are coming in. You mentioned V6. It's all over. No, Eric, why are we not all deploying it, especially North America? We seem not to be going at a snail's pace.
So I think the work that people are doing on RPKI, I think it's got a lot of interesting merits. I think it'd be interesting to have a discussion about the sorts of things that people see it actually remediating in the longer term as well. I think there's a handful of things that it proposes to do, and there's a handful of different ways in which you could imagine doing some sort of resource certification. But RPKI certainly is a design that's codified to help you do resource certification for people that hold IP blocks. I think it's not completely straightforward how you immediately use that in your routing system. I think the envisioned path of going through something called BGP-SEC takes a number of years for that thing to be standardized and then for routers to be forklift upgraded and stuff like that. But that's a separate story. Right now, what I think people are doing with RPKI is they're trying to say, this is a resource holder of, for example, IP space, and here is how you can go and verify that this resource holder is actually genuine. It's a brand new system with a great deal of cryptography. I think one of the things that we've learned in a lot of cases, but I'll just pick on something that I actually have a lot of admiration for, DNSSEC proved that putting crypto into something that hasn't had crypto for 20, 30 years is hard. Just if for no other reason than we're just not used to dealing with it. And so there's a handful of sites that track various aspects of RPKI, and it's got a lot of shakeout that needs to happen before we can really feel comfortable that it's an operational system we can hang on.
Merike, Aaron, for instance, and some of the other R's have, turnkey systems, click, sign. What's the problem?
Yes, I think one of the biggest problems is that people, as Eric was saying, they're uncomfortable using certificates. And my comment is that please don't let that be a problem, because actually the utilization of certificates is the only way that you're going to get any kind of scalable authentication in any kind of futuristic protocol, be it DNSSEC, be it people who are actually deploying TLS or IPsec, and so on and so forth. The comment I want to make specifically to RPKI is that I was at the IETF, and there's an IEPG, which is a meeting that happens on Sunday morning, and a person from Ecuador was talking about their RPKI implementation. What struck me, and this is something that was interesting, is that while they're deploying it, they haven't yet made a decision in what they're doing with invalid routes. But they've gone at least through the exercise of getting their certificates, signing their route origins, and then the factor that still has to be decided on, what do you do with invalid routes? And when Sandy was saying, look how many people have deployed it, the question that I want to know is, what have people done with invalid routes? Are they actually dropping them, or is it still we don't know yet, we're going to wait and see?
Okay, so I have to clarify what I said earlier. What I was reporting was how many people have certified their prefixes and generated ROAs. I was not saying how many ISPs are using that information to judge whether a route is valid or not. That's an independent decision that every ISP is making, and we don't really have public knowledge of people who are doing that already. It is possible to take all this stuff and feed it in through your prefix filter generation engine and come out with prefix filters, so that would not really show up all that well in trying to decide whether people were using it or not.
But we have to make some forward progress, and I'd love to hear from somebody, if somebody's willing, if they've heard of RPKI, Ben, just have a question, or some reason why they just aren't willing to do it, or they're something that's keeping them from moving forward on it. But first, we've got a comment here.
Hey, Jan. So my comment is, so how hard can it be? So when I deployed RPKI in my production, I measured the time, and I needed with the virtual machine generation and putting the validator in and configuring the router, I needed 17 minutes.
17
minutes to configure from the scratch to a working validation on my Cisco router. So how hard can it be? The next comment about the invalid routes. I'm installing them with the local pref of 90 for the moment. I don't have the cojones to drop the invalid routes yet. And my actual question is, do we have any data on, is there any activity going on to work on a path validation, not just origin validation?
Okay.
Do we have any activity going on? Are we building the software? Are we working on it?
Okay. Do you want me to?
Yes.
Okay. The route origin attestations called ROAs are used to validate the origin of routes, right? Not the full path, just the origin. There's other work going on in the CIDR working group right now to define a protocol that would validate the whole path. The route origin validation, you don't need to do any crypto in the router. All you need to get is a list of valid origin and AS numbers. Who's the valid originator of the route? The path validation is what Eric referred to as BGP-SEC. That's the next generation of this work. And there are people working on implementations. I do not have a view into vendor implementations. All the ones that I know of are open source.
So, but just to sort of clarify, so, and this goes back to something I mentioned at the beginning, not to sort of overly conflate things. So one of the prospects of BGP-SEC is path validation, forward signing. And one of the things that you might be thinking is that therefore I can trust things that go over this control path. But really that only talks about the message, the path that the update message traversed. It doesn't help you understand whether that route should have been propagated across a peering link. So it doesn't have that policy aspect. And that's in the design, it doesn't really account for that. So that's one of the sort of the fundamental missing parts, is that if you worry about things like route leaks, this is not the path validation that's going to help you. This will just ensure that an update actually traversed the path it said it did. It won't tell you whether the route was, whether the policy that spawned that route was valid or not.
Right.
Thank you for that question, Jan. And of course, he's available for consulting, but 17 minutes, that's the most he can bill you for. Just remember that. We have someone who's, I think, willing to give us his concern or comment. Go ahead, sir.
Sure. Sure. My name is Ross Halliday. I'm with WTC Communications. As we're sort of on the internet, almost the equivalent of an end user in that we don't really have peers as much as 3 full BGP tables. Filtering and path validation are very difficult for us since it would be everything at the same time. So it's very frustrating to see other operators not doing their own filtering properly. Our PKI sounds very, very interesting but from my perspective on the receiving end, it's very similar to email technologies like domain keys identified mail or DKIM or sender path framework. As a sender, it sounds like a great way to secure your identity and prevent you from being spoofed, but it doesn't do anything for spam. How does this address the problem of DDoSs in a system that is legacy compatible with user error, basically?
Who'd like to jump in on that one? Okay, I'll pick on Merike.
I want to make sure that I understood the question correctly. So, I mean, from your perspective, are you asking that how would the path origin or the route origin validation handle issues like spam?
No, sorry, more like any spoofed IP. So let's say Comcast, they issue RPKI certificates and have their entire address space signed. Someone else on a different network could still spoof the IPs of another provider that does not have any such signing in, and even with validation in place, I would never drop those routes. I would still get all the spoofed IPs in from a provider that isn't doing any filtering.
I guess a little bit until everybody's deployed, what's the use kind of thing? So if there's still people who aren't RPKI, what's the point of it, I think, is the question.
Yeah, well, you've picked somebody on the panel that is not necessarily somebody that 100% believes in RPKI, yeah. So, I mean, this speaks to you have to understand in your environment how much value or worth is it, what kind of risk mitigation are you actually getting worth the effort versus the effort that you're putting in. the thing though with technologies like RPKI is remember that it has local value, right? So it would be interesting if, you know, most people were actually doing some kind of ROAs, right? So that they actually attest with certificates that I'm allowed to send this route. But the thing is that how do you validate that even, right? You're trusting somebody with this information as you're getting it. And if, I mean, I don't trust anybody, right? So I'm even thinking about certificates,
to the end.
right? And so in my point of view, you're speaking exactly to the issue that people have to think about. If only half the population does RPKI and only half the population does any kind of filtering, what is the issue from the overall global routing stability, right? But at least if most people do believe that a combination of both, so that if everybody actually has the means to certify with certificates, and let's say that I trust them, right? And that you know that most people are doing this, it won't solve every single problem, right? Because people can still inject the wrong route. If you don't validate, well, you can then propagate this, right? But if people also utilize filtering, then as a combination of defense and depth, I think you can solve more of the issues.
Okay, we have time for just 2 more comments or questions. So our next one here, we have a local IX willing to comment here.
So, John Nister from Torix. One of the things we notice, at least with our route server implementation, for example, we have 170 peers, about 100 of them use the route server. We talk about things like RPKI, which is fantastic, but I think, I'm not sure having folks look at RPKI and dive right into it right away is a good idea if we have problems with some of the basic stuff, right? We have issues with peers that have routing registry problems, don't do prefix filtering correctly, and you start layering on RPKI, I think there's going to be this ton of confusion that goes through. So I think people really need to understand the basics before they move into something a little bit more complicated.
Are you saying that if they can't get that right, they probably won't get the RPKI stuff
That
right?
is absolutely what I'm saying.
Okay.
But he won't name names. Any comment on that, or thank you?
Well, there's the other possibility, which is that, you know, if you realize you got to do RPKI, you got to do it for real, maybe this will cause you to clean up your house as well. So I don't know. I don't know which way to go on that. I mean, it seems to me that it's at least as likely that if you've actually got to go through and you know, do it correctly in order to do RPKI, then that's your opportunity to fix it. We know that a considerable number of errors have been caught by people deploying DNSSEC. That was sort of painful at the time, but it means that their maintenance of their DNS systems have gotten better as a result.
And do we not think, by the way, you know, much like, you know, with SMTP, it used to be that everybody had an open relay and it was a name and shame, and that caused people to up their game. Do you think we'll see this with that? Is there?
It could be, anyway, as I'm saying.
Any other comments?
It's also possible that some of the features of the RPKI will prevent some of the bad behavior in routing registry sorts of things. The unauthorized registration, the stale data, that sort of problem.
Eric, last comment?
Do you mind?
Go ahead.
Oh.
No. Eric and then.
Yeah. Okay. So I just want to, I think that's a great question. There was a handful of things that I think were subtly made in that question, points I don't know, I think you probably meant to make. And one of them was, you know, principled building block. Like at the bottom, we're doing certain things. There's sort of we're building on top of. Let's get those right. Let's get the fundamentals right. If we're a basketball team, we'd learn how to pass before we learned how to slam dunk. You know, lots of stuff like that. I think that's very critical. I also want to point out that when you're talking about managing peering, whether it's filters or anything else, you're talking about a much different model than a hierarchy put on top of it. Like as opposed to like, hey, like the DNS is hierarchical. It is. There's a root, there's top level domain, so on and so forth. Putting an authorization model that's hierarchical on top of that kind of makes sense. When you look at your peering system, which is not hierarchical, and you take a hierarchical verification system like RPKI, you do have 2 separate models. And if they don't work well together, it could be because they're doing different things differently.
Okay.
Well, the RPKI
we're going to have to unfortunately go to our last question because I know we're out of time almost. So,
okay.
But we'll have our last question. Although for those that you didn't get to answer, I know not all of our panels will be around, so feel free to grab them.
Yeah,
I'm sure they'll be happy to talk. So the last question to you, sir, and then we'll go for any last thoughts or wrap up from the panel.
Hi, I'm Ronald Gruy. I'm Director of Research at Frost & Sullivan. So as an analyst, I'm going to ask a futuristic question. So I'll ask each one of you to put on a Jules Verne cap on. And for a minute, imagine the world maybe, I don't know, a few years from now, 2017, where we see, you know, SDN, we slightly touched on the last, it's a subject that's very near and dear to my heart. But we see a future in which certain functions, like for instance security in routing, basically become a service. We already have solutions from vendors like Radware, Embrain, etc., that are already doing that even as we speak. But you know, do you see maybe in the future a higher percentage of the routing just becoming, you know, the stuff that kind of vendors like Cumulus is offering now, where it's basically, you know, bare metal, and some of these functions like, you know, resiliency, security, etc., are being done by other vendors, and maybe, you know, there'll be that shift from, you know, from a hardware-centric model to more, you know, software and services? And how long do you think that's gonna take? Thanks.
Quickly, for anyone want to jump in on that one, or anyone feel in a predicting kind of mood?
You know, I can see that validation is going, and automated validation is going to be something that more people are going to be concentrating on. So, but it all depends on, do you have time, right, when you're making these quick decisions about whether or not you're going to be passing a packet or not, right? Do you have time to actually go somewhere else to double check? And I don't think that's going to be the case.
So I apologize, we have run out of time. Oh, sorry, one last comment? Yeah. So I'll just ask the panelists if there's, you know, a quick comment they might want to have on what they've heard, or just how we may be able to move the rock forward a little bit on this. Do you want to go first this time? Or?
Oh, golly.
Sorry. Picked on Andrew last time. So.
Well, the prefix allocation system has been around forever. It started off hierarchical, and it's kept up with that. The protection system that we have to build for a hierarchical allocation system is going to be hierarchic. It's something that concerns some people. A lot of the features can be developed as outsourced services, as the gentleman suggested, but routing has to work before access to services like that can be available. So I'm not certain whether the actual distribution of topology information for routing is going to be possible as an outsourced service. We have some work going on, and hopefully it will continue to be, see uptake in other regions, so hopefully.
Thank you, Merike.
Yeah, for me, I think a lot of the technology has been created to actually secure routing infrastructures. What's really needed is for operators to get their heads around how they do it, how they create their processes, internal processes, to actually make it a reality. And as the gentleman in the back, you know, had pointed out, well, we got to clean up our house. I fully agree with Andrew that actually nobody's house is clean. And so this is a way for people to look at, you know, auditing, what do we have, right? How do we now tie it into some kind of cryptographic integrity for our, either our routes or DNS names and whatever. And as I've seen people go through the process, they're discovering all kinds of things that they can now clean up. So I would encourage people to actually starting to clean up. And I don't think just doing the basics is the only way to do it, but actually looking at how do you tie that into possibly utilizing RPKI and DNSSEC.
Eric, final thoughts.
So I'm a big fan of not trying to boil the ocean and not put too many things together. But at the same time, a couple of things that we've touched on today really feel like, and I feel like I'm worried there's a little confirmation bias on this, but I think that there's a couple of things we've talked about that hit a broad swath. So the extent to which you worry about certain problems like route leaks or reflector attacks or other things like that is the extent to which you might be talking about anti-spoofing, you might be talking about filters, you might be talking about the same kind of idea of how do I just make sure that when I get a route across a link, whether it's a customer link or I am the customer, it's to my whatever, I take care of that and I make sure my policy is understood and processed correctly. If you were to do something like that, just simply make sure that policy semantics were abided by, you would potentially be able to deal with spoofing, you'd potentially be able to deal with route leaks and misorigination. So it's a fundamental, simple building block at the bottom, and I mean simple not as in that it's easy to do, or we all would have done it, but it's a small atomic step that has a big win involved. And so whether you're talking about RPKI or anything else, I'd look at what are the semantics of the building blocks to solve the problems I care about. And I think we've talked about a lot of them today. And I think you guys have probably talked about them in passing before. But focus, on what solves the biggest problems for me. And I from what I've heard from a lot of people before, filtering is a big deal, and it solves a lot of problems.
Andrew, final thought.
I think that's exactly right. I have to say I was mighty encouraged to see that there's nobody here who has any problems with their filters. So already, obviously, Canada, despite lagging in IPv6, is way ahead in the cleanliness of our routing system. That's a solid foundation on which to build. I'm therefore a little concerned at John Nister's observation that it'd be too dangerous to turn this on because it'll all catch on fire. So one of these has got to be true, and I'd like to hope, in fact, that you can all go home and say, hey, this is all great. We can, in fact, build on this solid foundation that we've got underneath. But as Merike said earlier, trust but verify. Check your filters and see how it is, and then use that as the basis on which to move forward with a more secure routing system, because it'll protect your business model in the end.
Well, much like the Oscars, despite our best intentions, we've run desperately over time. So I'll keep wrap up. I'd ask you, all our panelists have traveled a great distance, some from Vancouver alone, just from the IETF. So if you could all just give them a round of applause for their time today. Thank you. And